The Volkswagen system is the first of 3 energy systems to be used during exercise, and it involves a phosphocreatine being broken down into creatine and a phosphate, releasing energy in the process. Well, this reaction here is called hydrolysis. Then an ADP will react with the phosphate and the energy to form an ATP unit very quickly, while the conversion of ADP to ATP is called phosphorylation. The next energy system that will be used would be anaerobic, very important to not confuse with aerobic. Anaerobic glycolysis, also known as the glycolytic system. It involves a glucose being converted into pyruvate, releasing 2 ATP units quickly, not very quickly, unlike the Volkswagen system, and releasing lactate as a waste, and this causes the burning feeling you may feel during exercise. The oxidative system, when using carbohydrates, is going to use, well, glucose obviously, and this time it's going to convert it into pyruvate via aerobic, not anaerobic glycolysis, releasing the 2 units of ATP that we already know. This time the pyruvate is going to be converted into acetyl coenzyme that will enter the Krebs cycle in the mitochondria. Remember that this part is in the mitochondria. It will release hydrogen ions that enter the electron transport chain and also produce ATP. The total yield of these 3 sections, so the mitochondria, is around 36 to 38 ATP units in mitochondria. This system can also use fats or lipids as its source of energy, and this involves a triglyceride being broken down into a glycerol and 3 fatty acid chains via the process of lipolysis. Then they will be converted into 1 acetyl coenzyme via the process of beta oxidation. Remember this detail is that the chain is broken down by 2 carbons every 4 reactions in order to produce 1 acetyl coenzyme, and then the process in the mitochondria that we saw previously will be repeated. If you have trouble memorizing these 3 key words, just look at the last part. If it involves genesis, it is producing, and if it involves lysis, it is breaking down. Okay, so make these links and understand them. If it involves glyco, it involves glycogen. So in this case, lysis is breaking down and glyco is glycogen, so it is breaking down glycogen. And what is glycogen broken down into? Glucose. In this case, glycogenesis is producing glycogen because it is Genesis producing in glycogen, and from what is it produced? From glucose. I hope that makes sense. Now let's delete this as quickly as possible because we're going to look at the energy systems. So, well, this isn't really an energy system. It is the default ATP that is already in your muscles. It's the ATP that is present before any energy system. It's around 2 units, and it involves immediate release that lasts around 2 seconds in any exercise. Then there are the energy systems that we saw before. As you can see in the exercise column, the longer and less intensity of the exercise, the more last resort, you could say, the energy system is. So as you can see by this table, the earlier an energy system is used, the faster it is going to be, but that also means that it's going to run out faster. Okay, so this we actually have seen before, just in a more visual representation, but I thought it would be good to have a written or verbal representation as well. So take your time to memorize this and look back through the video as well, because that's going to help you well understand all of this text.